So when we are talking about processes, so processes will cover around 5 lectures. So we will learn about processes and what they do and how the process switching happens in lecture, two lectures, that is M2L1 and M2L2. Then a process also contains some minute threads of execution that we also learn in lecture number 3, that is M2L3. And we will learn about job scheduling that will compose of two lectures, that is M2L4 and M2L5. Okay. So now let us understand what is actually a process. Okay. So basically, this is your program. You have written a very simple program, that is main program, right? Now it in here starts with this execution, that is this one, the first bracket, and you have written this code, simple line of code, that is printf hello world, and you have closed this statement. This is a very simple execution code, and you have sorry, this is a very simple program you have written, and you have saved this as hello world.c. So basically, this is the program code or data, or if you can say the text also, you can say it. Now, this is stored somewhere in your computer, right, in some folder, right? Then what you do? You start compiling it. And from compiling it, what do you get? You get this one, that hello world.exe. First, you link all those modules of it, the linker is there. Then you have to load all those modules that are required for running it in the memory. So ultimately, a machine learned equivalent code is created that is called hello world.exe. Now, this program in here, this text in here, which exists, somewhere in your computer hard disk, is nothing static. But when you are converting into .exe file, you are converting it into something much more of a dynamic object, right? It is a simple static code, but when you are trying to execute it, it doesn't remain a code actually. It becomes something called executable, right? It becomes much more dynamic, and this is something that is going to run in the memory. So this program and this process is entirely different. This is simple text, and this contains a lot of other variables, including global variables, local variables, dynamic memory it can address, header information, and every other kind of information that it contains to run in the memory. And when it is goes into this one, that is the processor, then it goes into this RAM, and then it tries to execute in the CPU. It becomes much more dynamic. Now, program and process are something different. This thing that you see in here is basically the program. But when it is going to run in the memory, it is called a process. Now, there is something you have to also understand. Program is much more like a static, right? It doesn't do any function, but process is dynamic. It goes into the memory. From memory, it jumps into the processor or the CPU for running. It takes it stores its temporary variables. It stores its data. It has its own memory location where it stores the return addresses of functions. It uh, it allocates dynamic memory to its new variables or new data to be created. So basically a runtime environment. So it becomes much more of a dynamic thing, right? It is always changing, but program code is static. It doesn't change. So it might happen that you should know that, okay, fine, I am still not understanding this, right? Now, what do you mean by that? It's a program and it becomes a process, and process and programs are different. How it is different? All are same because it's the same code. No, it's not the same thing. Why it's not the same thing? Because you see that when you are writing a Microsoft Word document, you are writing an MS Word document. Okay, now, when you are writing an MS Word document, it has basically what you do. You just create new document, right? And a new document space is created for you. A new document space is created for you. Now you want to create another document. Now you open Doc 2. Now you open Doc 3. Now you open Doc 4. All are getting opened. But you said this is only one single program. How are different is being created? Only one should be created, right? No, right? When you are double clicking on the program data, that is MS Word, you are creating an instance of that code in the memory. It exists differently. So a new Word file is created. Again, when you are clicking on it, you are creating another instance of that same code in the memory that has a separate location. So you are seeing two different Word documents. So supposedly where one is your CV, one is you're writing a story. That is so two are different part. They are living differently. So those two are basically the processes which are basically we can say that are instances of the same program. So the program is static. So the new file that you are creating, those becomes dynamic. Now you have understood? Hello, hello, কি গো?
Yes, sir. Hello, sir.
তোমরা বুঝতে পারলে? Whatever I said, did you understand? Hello?
Can you explain? Hello, sir. Can you hear me?
Yeah, I can hear you.
Okay, sir. Can you
Do you need
repeat that
another
part once
explanation?
again? Yes, sir. Yes, sir.
Okay, fine. So let us take the example of a browser memory, computer browser. Okay, so now you opened a Google Chrome on your laptop. Okay, you are trying to execute it, right? So one browser open, browser window opens, one, but you double clicked it 3 or 4 times, so separately more are getting created. Right? But you are saying that the Google Chrome this program is same, right? But why why there are different windows being created? This is a simple thing you are asking. As per the logic that goes, there is one code and it should run only one, but it doesn't happen so. So whenever you are double clicking, you are creating an instance of that code in the memory, right? You are creating an instance of the program in memory, right? An instance of the program in memory means, so when you are opening the desktop, you see there is one browser window opens, right? If you click 6 or 7 times, there are second browser window opens, there is third browser it opens. So each and all of this process, which are basically an instance of the same code, same browser program, that is Google Chrome, they are executing in different parts of the memory, and they have their separate code section, there are separate data section, there are separate, what you can say, the dynamic memory, there is separate, what you can say is your heap memory, and there is separate your, what you can say, the stack memory. So every browser window that is open, which are instance of the same program, basically exists differently in different parts of the memory, having all their different memory sections different. So one may exist in one part of the memory, another can exist in the another part of the memory. That is how a process is different from the program. So this we can call as the program, but when it's in the memory, it's called the process. Now you are understanding?
Yes, sir.
Now the thing is clear.
Yes, sir.
So what is the concept of process? Now let us go into some, what you can say, the formally we can define a process. So current day computer systems allow multiple programs to be loaded into program and executed concurrently. It can happen. So in one hand your browser is also running, in another hand in your word processor is also running. They can all be loaded into the memory and they can be executed together. So this is how the current day modern operating systems work. Now, what is a process? A process is a program in execution. Now, from the previous diagram, you have already seen that this is possible. A program is a passive entity, whereas a process is an active entity. Why we are saying it's a passive entity? Because it exists in the secondary memory. It is not working in the memory. It doesn't have any memory location allocated to it. It doesn't have any process registers addressed to it. So we are saying this as a passive entity. But what is that? Process is an active entity. It has its own memory. It has to be executed in process, so it has its own process control block. So basically, everything related to the process that it requires, a process has it to run in the CPU. A process is the unit of work in a modern time sharing system. So when you are working, so basically when you are talking about a unit of work, right? So in physics we talk about unit of energy is joule, unit of power is watt. So in uh, time sharing system, in modern operating system, which are basically time sharing, a process is a unit of work, right? A system, therefore, consists of a collection of processes. So there are two kinds of basically processes. One is the operating system processes, which execute system code, and there are the user processes, which execute the user code. Operating system processes means all the Windows related program which does the scheduling or the resource allocation, they are called the operating system processes. And then there's the user level processes, which are your processes. Basically, you can call them as Word. These are user level processes, or the Chrome browser. These are user level processes. Okay, this you understood?
Yes, sir.
Okay. So when a process is in memory, when a process is in memory, what is there? A program becomes a process when an executable file is loaded into memory. A program becomes a process when an executable file is located into memory. So we have to modify a program to get an object code or an executable file output. Now, executable file is also a passive, but when we are double clicking it or loading it into the memory, so we can do it using double clicking it, or you can write its address on the CLI command line interface. It gets loaded into the memory, so it becomes a process. So whenever an executable file is allocated memory or CPU time or IO time to it, it becomes a process. So what is a process? When it is loaded into the memory, what are its contents then? There one thing is called the text section, or the where the program code resides. So this part is called, one part is called the text section, which is very small part, and it is called the text section, and which contains the actual program code or actual the machine learning code. Then there is the stack. Stack is, so you see, it is a top down approach. So in data structure we have already learned. So what is there? It's a what kind of memory? Stack is what kind of memory? FIFO or
Sir,
LIFO? What is the stack? What kind of memory it is? LIFO or FIFO?
LIFO.
Sure na? Sure.
Yes, sir.
Okay,
yes.
fine. So stack is a last in first out memory. So in here, what you do? So if you call a function, or if you call it say basically function parameter, so everything is pushed on it. So the last function called is the last function inserted into the stack is the first function called or returns. That is how the stack memory operates. So the stack contains temporary data such as functions, parameters, return addresses, and local variables. Okay, all the local variables that are there in the local functions. Then there is the data section where you can write all the global variables. And the last is the heap, which is basically dynamically allocated. So if you are, what is the dynamically allocated memory location in data structure? Hello, hello.
Hello, sir.
What is the dynamically allocated data structure? Dynamically memory allocated. What is the dynamic memory allocated data structure that we learned in the data structure class?
Malloc.
No, that is there. That is, of course, that is how you do it. But what is the data structure you used?
Linked list.
Correct. The linked list. So there are four parts, or there are basically whenever a program or whenever there is a process, it has four parts. The text, which contains the program code; data, which contains all the global variables; heap is the already the dynamically allocated memory; and stack is all the temporary data such as function parameters, return addresses, and local variables. That's how a process is represented in the memory. Okay. Now, in here we come into another definition, that are what are the process states. Acha, this you remember all your life. Okay. That is text, stack, data, heap. Text, stack, data, heap. Text is the program code, stack is the temporary variables, data is the global variables, and heap is the dynamically allocated memory. Right. This you will often come in this diagram will often come into your life as a system programmer or as a programmer. Right. Or if you in a interview also some questions may arise. So this is related to that. Now there are different process states. So process states is what? Basically, process state defines the current activity of that process. So a process, immediately you double click it or print its name into the memory, immediately gets executed. It is nothing like that. In modern day operating system, it doesn't happen like that. So what happens in here is basically a state, which means there are different, what you can say, the current different activities of the state, and operating system developers have basically used different terminologies to define these activities of a process within the CPU or within the computer system. The first is the new, when the process is being created. So as soon as you double click a process, or as soon as you double enter its name, that is dot slash a dot out, and you put that in the basically in the command line interface, that stage is called the new. So new is the stage where immediately some system variables related to the process are created, like program counter and all the memory systems that are the registers that we will use. So everything is developed and it is allocated to the newly created processes. Right. And then there is the running. So now process is running means it is in the CPU and it is executing its different types of the code, different parts of the code. So there are different program lines of codes, or different lines of codes are being executed. Now waiting. The process is waiting for some event to occur. So the process is waiting. So if a process is waiting means it may wait in different parts of the memory, different parts of the CPU. It can be waiting in the IO queue, or it can be waiting in the basically running queue. So it is waiting. Ready means the process is waiting to be assigned to the processor. That means the process is there, but it is where in the memory. Terminated means the process has finished its execution and so the first stage of a process is new, the last stage of a process is terminated, and in between there are three stages, that is whether running, it is either executing the CPU, or it is waiting for some event, or it's in the ready, that means it is in the ready queue, or it is in the memory. So let us see. So this is the new system that is created, and when you are admitting it, it is goes into the memory. It goes into the memory and it is in the ready state. So ready state means it is just waiting for it to be executed. Now this is where the running state is. Now from the ready, a scheduler dispatch happens. So we'll learn about scheduler dispatch in the next class. One second. It waits for the scheduler dispatch and it is running in the CPU. Now, when it is running in the CPU, there are two things can happen. One, an interrupt may happen. An external process or a system process may interrupt the running process and ask it to leave the system. So in that case, a process does a state save. Wherever it was stopped executing, it saves the state and it moves to the ready queue. Or an IO or some event happens, it goes to the waiting state for that IO event or the other event to be complete, and then it is again submitted to the ready queue. Okay. Finally, again the scheduler dispatch happens, it again goes into the running queue and it executes the last instruction or the last program or the last line of code till it is executed. It is in the remains in the CPU, and finally it exits the system and it terminates, means it has completed its execution. So these are the what you can say five normal states of a process. There are multiple other states. So as per different operating systems, these states numbers may vary. So in Unix, it may be different. In Windows, it may be different. In Apple or in Macintosh systems, it might be different. Right. So if you see, so this is the program code or data. So when it is running, so when you double click it, it goes into the RAM. So somehow in the RAM it exists, on the memory it exists. It is allocated to the CPU where it is executing its instructions. Then some of the things may happen, interrupt may happen, or IO or some event may happen. It gets into the waiting stage, or it may go to the ready state, and after again it goes into the running after the scheduler dispatch operation, and it may exit after completing its last line of code or last execution cycle, and then it terminates or leaves the system where it gets executed. This you have understood? এই ক্লাসটা বুঝতে পারলে process states. Hello.
Yes, sir.
Hello everyone.
Yes, sir.
Yes, sir.
Rijjola, আচ্ছা তুমি তো পাশে আছো রিজ্জলা? দীপ্তিমান, কৃতিয়ান বলেছো, রাহুল বলেছো, বিদিশা বলেছো, সোনিয়া বলেছো. Every one of you understood, right?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So how many states are there? New, ready, running, waiting, and lastly terminated. Okay, but as per operating system, it may vary a little bit number. Okay, now we are going into the next step. That what is a process? Means what do you mean when it is a process? Means actually we are telling it is a process. It exists in the memory, but what does a process actually mean within the CPU? What does a process actually mean in hard coding terms? What it does actually mean within the CPU? So there is a process state which defines the current state it is. Then there is a process there is a program counter which indicates the address of the next instruction to be executing for that process. The process has multiple execution cycles for each of its instructions. So the program counter stores the next address of the instruction to be executed. Process number defines the particular ID of that particular process within the CPU memory. So you can easily use the command psaux in the Linux operating system and can see which process ID it is there. Then there are registers, means which are the CPU registers are there which are allocated to it. So CPU registers may be the accumulator, the basically what you can say the IO registers or many kinds of registers are there which are allocated to the process. CPU scheduling information is basically the scheduling information, right? Which if it's the round robin or it's the first in first out, whatever the CPU scheduling information it is, but when it is going to be executed in the CPU, that information is there. Then there is the memory management information, what is the base and the limit registers. We will see all of that in the later classes. What are the accounting informations, how much CPU time it used, how much IO time it used, how much times it was required, how much space it required. So these are all the accounting information. IO status means what are the basically the input output, what are data it took, what are the data it has taken, what is the data it is restoring. So these are all basically the IO status informations. What are the basically devices it has used. Okay. So this is basically when you're talking about a process control block, you are actually a process is basically nothing. It is defined by the process control block, right? Process where each and every part defines a particular the what you can say the current stage or the current state of the process within the system. There is a process state, program counter, CPU register, CPU scheduling information, memory management information, accounting information, and IO status information. So that is all about the process control block. So it might happen when there is an interrupt is happening. So the what does the operating system do? It does a state save, means it saves all the process related information, that is state, its number, its program counter, registers, memory limits, and it moves that process from the CPU to the memory. And when it's time to execute the process again from the in the CPU, it does a system restore. The operating system does a system restore, where each part of the process starts from where it ended, right? So this is often done in the modern day operating system. So a process, so this switching of a process from the CPU to other work and from other work to CPU is done using this process control block, or what you can say manipulating the process control block by doing system save or system restore. এটা বুঝতে পারলে? Did you understand this one?
Yes, sir.
Okay, everyone understood?
Yes, sir.
Yes, sir.
So process scheduling. A new process is initially put into the ready queue. It waits there until it is selected for execution or is dispatched. Once the process is allocated the CPU and is executing one of the several events put off. So a process is in the ready queue. It is waiting there until it is elected for execution or is dispatched. So the process is allocated the CPU and is executing. So it is in the running state, right? There are several events that can occur. The first is that the process could issue an IO request. So it wants to do or take some data from the hard disk, or it wants to take some data from your floppy disk, or it wants to send some information to the what you can say the network device to transmit some information or wait some information. So then it is placed in the IO queue, right? Then the process leaves the CPU, it does a system save, and it leaves the CPU and goes into the input output queue. So an input output queue means an IO device or input device or an output device also has a queue similar to the ready queue that is in the memory, and it stores all the process related requests that a process may require. So the process is waiting for that IO request to be over, and then it could be allocated, then it can be allocated to the main memory again. That is what you can say as the IO request. And there the process waits. So that is the what you can call the waiting stage. Now the process could create a sub-process and wait for the sub-process termination. Now a process is executing in the CPU. What it does, it creates a sub-process, right? It does a fork and creates a sub-process, and it must wait. It leaves the CPU. It leaves the sub-process to work on the CPU to complete. It gets the data from the sub-process, and then it is again allotted to the ready queue. Okay, that can also happen. The process could be forcibly removed from the CPU as a result from an interrupt and put back on the ready queue. An interrupt as an external event. Supposedly a virus attack happened. Supposedly you want some of other process to run and you want to remove the current process to leave the CPU. You can do it through an interrupt and you can forcibly remove it from the CPU. So it might happen. So you always do it. Sometimes you do control or delete and start the task manager, right? And in the task manager, you see some of the process that are running in the CPU. So what you do is select one process, you kill that process, you forcibly end that process, and so basically what it does, it removes the process image from the memory, but it actually does means it remove from the memory. So some other time that process may be put into the CPU for its working, right? So that is what you can call as an interruptive. So each queue runs its own separate scheduling algorithm. So there is a CPU queue is there is an IO queue is there, and each of them has its own separate scheduling algorithm. We'll learn about scheduling algorithm later. So what is the process scheduling? So basically this is a new state, right? This is a new, and this is what you can call as the terminated. A process is that when it enters into the ready queue, it's basically new. It goes into the memory, and from memory it can go to the CPU. From CPU, many things can happen. Either a IO request has happened, or the time allocated to it has expired, or it has created a child. The child executes, or it is an interrupt has happened, and the interrupt completes its jobs. Then, after these things happen, then only the process can be moved to the ready queue. So for each IO, there is a queue. It will completes the IO, then it is submitted to ready queue. After the time slice expired, it goes into the ready queue again. After the child executes, it goes into the ready queue again. Interrupt occurs, it goes into the ready queue again. If all these processes are complete, then the process completes its whole job, and then only it gets terminated. So that's how the process scheduling works in a system. Okay, now there are different kinds of schedulers are there. What are the different kinds of schedulers? Okay, now it's 11:45. We will start our class again at 11 o'clock. Okay, sorry, 12 o'clock. Hello.
Okay, sir.
Okay,
So
sir.
you can give your roll number in here. I'll note them down later. Just put your roll number in the previous class. We'll start at 12. Okay, I will send you this PPT. Just start reading. Okay, very important to read every time. Okay, thank you. We'll start again at 12. I'll give you a new link.
Thank you, sir.
Okay, thank you.